Now we're going to talk about the washer method when you're rotating around the y-axis. There's a few key differences when you're doing this, and the first one I want you to notice is that A and B are on the y-axis now instead of the x-axis. That's because when you rotate around the y-axis like this, the cross sections of the circles are going up and down instead of left and right. So you're going to want to find the area of those infinite cross sections between A and B going down from up instead of left from right. So your limits of integration A and B are actually going to be y values instead of x values. But the easiest way to find those y values is to actually set these functions equal to each other and find the x values of where they intersect first. So you're going to do x squared minus x equals 0, factor out the x, get x minus 1 times x, and the two points where they intersect are x equals 0 and x equals 1. So what you're going to want to do is input those back into, you only have to do one of these functions and you will get the y value. So with these it's easy because they're pretty simple functions, so I'll just use y equals x. So when x is equal to 0, y will equal 0, and when x is equal to 1, y will equal 1. Usually they won't be the same like this, but in this case they are. So your limits of integration for this problem are going to be 0 and 1. So now before we set up our integral, there's one more thing we have to do. Because we're rotating around the y-axis, we're actually going to be integrating with respect to y. So we have to change these functions to be x equals whatever. So with the first one, it's easy. Obviously, it's just x equals y. And then for this, for y equals x squared, it's going to be just take the square root of x and x equals the square root of y. So these are going to be the two functions that you use to integrate in your equation. So in these cases, big R, or f of x, is going to be the function on the right, because the function on the right will have the furthest distance to the y-axis, and the function on the left will be g of x, or little r. So the setup is going to be v equals pi times the integral from 0 to 1 of the square root of y squared minus y squared with respect to y. And it'll look like that. So from that point, it's the same exact process. You're just dealing with y's instead of x's. So first you're going to simplify these two terms, end up with v equals pi times y, the integral of y minus y squared with respect to y from 0 to 1. And you go ahead and integrate, you get pi times the quantity of 1/2 y squared minus 1/3 y cubed evaluated from 0 to 1, which will give you the volume equaling 1/6 pi, which here means when you rotate this area around the y-axis, the volume of the solid that's generated is 1/6 pi. Our second example is the area bounded by the lines 32 minus 2x, 2 plus 4x, and x equals 0, and we'll be rotating around the y-axis again. And the first thing we want is a and b, and this is kind of more, this is a little weird case because we're not looking for the intersection between these two lines because it's on the y-axis. We're looking for the intersection of each line with x equals 0. So it's going to be, so we're just going to substitute in 0 for both of these equations. So y for 2 plus 4x, it's going to be just 2. And for 32 minus 2x, it's just going to be y equals 32. 2 will be a, and 32 will be b. And those are our limits of integration. And the thing about this question is when you look at the graph, there's no clear right or left function. So what you have to do is split them up like this, and we're going to use two integrals actually. And for this top part, we're going to use 32 minus 2x as our function and rotate it. And for this, we're going to use 2 plus 4x and rotate it. So what we're going to have to do is split up the limits of integration. So we have to find this point, and its y value is going to be where we split them up. So that's where these two lines intersect. So we're going to set those equal to each other and solve. Equals 2 plus 4x. So it's going to be 30 equals 6x, and x equals 5. And then what we want is the y value, so I'm just going to plug that into this equation. So we'll get y equals 2 plus 4 times 5, which will give you y equals 22. So what we're going to do is split these up at y equals 22 and use two integrals to find the area. And don't forget, because we're rotating around the y-axis, we're going to have to change these equations to be in terms of y. So I did that over here. Y equals 2 plus 4x is going to end up being x equals y minus 2 over 4. And y equals 32 minus 2x is going to end up being x equals 32 minus y over 2. So when we set up the integrals and split them up, it's going to look like this. So the first one is going to be v equals pi times the integral from 0 to 22. That's this bottom part right here. Our first half is going to be y minus 2 over 4 squared with respect to y. And the second part, the top part, is going to be pi times the integral from 22 to 32 of 32 minus y over 2 with respect to y. And then we can just factor out that pi and rewrite it that way. And then after a lot of integration, you end up with v equals pi times 1/4 times the quantity of 1/2 y squared minus 2y, which you'll evaluate from 0 to 22, plus 1/2 times the quantity of 32y minus 1/2 y squared, which is evaluated from 22 to 32. When you do that and add them up, you'll get v equals pi times the quantity of 99 over 2 plus 25, which will give you the volume equaling 149 over 2 times pi, which of course represents the volume of this area being rotated around to form a solid 3D shape.